Hi friends, welcome to the Unit 2 Day 8 notes. This is the last set of examples. We're going to talk about function composition with rational equations. When you have rational equations, it brings in another set of complications. For this one, remember we can't divide by 0. So when we're doing function compositions, when we find the domain of the values, we have to find the domain of what's allowed based upon not only the function composition, but also of whatever you're composing with. So it says f composed with g of x. So whatever the domain of g of x is also going to play into what the final kind of result or value is. So what I'm going to do is I'm actually going to go through and do 21 and 22, finding this part first. Finding the composition, because we need the composition to find the domain. So we're going to, in effect, be doing 21 and 22 kind of before 19 and 20. So it says so I'll just jump down here, find f composed with g of x. So then we're going to take g of x, 2 over x, and we're going to substitute it in wherever we see an x into the f of x. So this is going to give me, so f composed with g of x is equal to, so that's going to give me 3 times 2 over x. Notice I'm being very careful with how I'm writing this. Divided by, or over, 2 over x minus 1. Now, in this instance in the denominator, I don't really need the set of parentheses, but it is helpful to see, again, when you subtract 1, remember you're subtracting 1 and I'm aligning this as the numerator. So to be able to kind of simplify this, the numerator here, 3 over 1, I can just multiply that times 2 over x. So that gives me 6 over x here. And then for here, we need to subtract to combine like terms. So I'm going to have to combine x, have to multiply an x over x here to go ahead and combine that. Let me show you with a different color what that's going to look like. So I multiply x over x. I don't know if you can tell that's a different color. It is, I promise. So let's see. 2 over, so this is going to be 2 minus x over x. There we go. And then now we can just simplify this. Remember, when we have a rational divided by a rational, we can multiply by the reciprocals. It's going to be 6 over x times the reciprocal. So that's going to be x over 2 minus x. These x's cancel, so 6 over 2 minus x. So now when we find the domain, we need to find the domain of this value. So we set 2 minus x not equal to 0 and then solve. Subtract 2 from both sides. Negative x cannot equal negative 2. Divide by negative 1, and you get x cannot equal 2. That's one of the values. Also, when we find the domain, we also need to find the domain of, again, whatever g of x is. In this case, g of x was 2 over x. So if we set x not equal to 0 and then solve, we get x is not equal to 0. So that's one of the values that we can't have. The other one is x cannot equal 2. So x can be any number we want. So in set notation, the set of x's such that x, element of the real numbers except for 0 and 2. In interval notation, negative infinity to 0, non-inclusive, union, 0 to 2, non-inclusive, union, 2 to infinity. There's that one. Plugging in 1 into this value, 1, we get 6. So f composed of g, you can write it this way too, f composed with g of x is equal to, f composed of g of x is equal to, so let's see, 6 over 2 minus 1, 6 over 1, which is equal to 6. That's that value. Similarly, when we find g composed with f of x, we're going to do a very similar path, except this time now we're taking the 3x over x minus 1 and plugging it into the g value. So g composed of f of x is equal to, so we're going to take 3x, we're going to take, my apologies, 2 over, and then in parentheses, 3x over x minus 1. Okay. A lot of students get confused on what to do with this value to simplify it. This set of parentheses here, being in the set of parentheses, tells you kind of how to set this up. This is really 2 over 1 all over 3x over x minus 1. Now, multiplying by the reciprocal, we get 2 over 1 times x minus 1 over 3x. That's going to be distribute 2x minus 2 all over 3x. Again, to find the domain, we need to set this not equal to 0, the denominator here. So 3x not equal to 0, so that means x can't be 0. And then we also need to look at our f of x as well, whatever value it's composed with. So that's going to be x minus 1 not equal to 0. Add 1 on both sides, so we get x cannot equal 1, which probably should have done up here in this spot, but essentially we have x cannot equal 0 and 1. So the set of x's such that x is an element of real numbers except 0 and 1, and negative infinity to 0, union 0 to 1, union 1 to infinity. And then the last part was plugging in 2 in for our simplified part. So again, another way of writing it, g composed with f of x is equal to, so it looks like I've got 2 times 2 minus 2 all over 3 times 2. 2 times 2 is 4. 4 minus 2 over 6. 4 minus 2 is 2. 2 6, always simplify, and we get 1/3. Sorry, it's shaking. Here we go. Thank you for joining me in these notes. I hope you have a wonderful day.